All right, the free response portion of the review. Let's start with the first one here. It says, in a certain voting district, the proportion of voters who registered as members of a specific parties are as followed. So they give me percentages of how people are registered. 48% of the people in this district are registered Republican. 43% are registered Democrat. 4% are registered with the Green Party. 3% are with the Reformed Party, and 2% are other. In the most recent presidential election, a random sample of 400 voters were surveyed as they left the polling place, and they said that who they voted for. So 197 people voted for the Republican, 153 voted for the Democrat, 32 for Green, 12 for Reform, and 6 for other. So the question is, do these data provide evidence that voters in the election did not vote according to their registered affiliation? So we're curious, did the number of people who are registered for Republican actually vote Republican? Did the number of Democrat match what they're registered at? So first, before I start writing the null and alternative hypothesis, can you guys figure out what test we would be running here? This is a goodness of fit. I want to know, does my data fit within the percentages that they gave me? So with that in mind, I want to know, do the percentages of those who voted Republican, Democrat, Green, Reform, and other actually fit? So there's a couple ways to write it, but here's how I wrote my null and alternative hypothesis. I went ahead and said the distribution of votes is the same as how they registered. When you're writing the null hypothesis here, you want to assume that these percentages they set up here are indeed true. So it's kind of a tricky way to say it, but I just said the people that voted, the actual distribution of actual votes is the same as what they registered as. And I went further and said Republican is 48%, Democrat is 43%, Green is 4%, Reform is 3%, and others 2%, just like it's claiming in the top portion. But the alternative is we don't think that it's true because we're trying to figure out, we don't think that they're actually voting to what they registered. So I said the distribution of votes is not the same as how they registered. Or in other words, at least one of those percentages is incorrect. Also, make sure you set your alpha level at some point in the state. I don't think I have that set already, so I'm just going to go ahead and write it in. All right, so let's go ahead and move down onto the plan step. Now, the plan step is where we say the name. Well, we already established this is a goodness of fit, so hopefully somewhere you said chi-squared goodness of fit. And we had to go through the random condition, 10% condition, and the large sample size condition. So random is I just copied above in the problem. It says random sample of 400 voters. And because I took a random selection, I went ahead and did the 10% condition as well, assuming 400 is less than 10% of all voters in this district. Or again, you guys could write it how I've usually been writing it. 400 is less than or equal to 1/10 of all voters in this district. Okay, that's another way you could have said it. District. All right. And then the large sample size or the large counts, the way you have to do that is we have to first check the expected counts. Do you guys remember how to figure out the expected counts? I like to go up to the observed and write them next to it. And so I went ahead and calculated all of those out. I went ahead and calculated that all of these are the expected counts in the parentheses. And I did that by saying, okay, we sampled 400 people. So I just took this 400 and I multiplied it by the 48%. I multiplied 43% by 400, 4%, 3%, 2%. I multiplied all of those percentages by 400 because if my sample size was 400, you would expect 48% of those to vote Republican. So that's how I got these numbers, 192, 172, 16, 12, and 8. So these are all of my expected counts. Are all of these greater than 5? Well, yeah, my smallest expected count is 8, and guess what? That's bigger than 5. So the way I said it in my conditions is I said the smallest expected count is 8, which is bigger than 5. Therefore, all the expected counts are greater than 5. Okay, so our conditions have been checked. All we have left to do now is the calculation part and the conclusion. So in the calculation part, remember what we're trying to do is we're trying to figure out a chi-squared test statistic. It's going to be drawn onto this skewed to the right distribution. We're going to come up with some kind of chi-squared value, and then we got to find the p-value under the curve. Well, how do we find chi-squared again? We take the observed minus the expected squared divided by the expected, and we do that for every single term, and then remember we find the sum of all of those after the fact. So I want to see you guys plug in some of these. You don't have to write all of them, but I would start with the first one. 197 minus 192 squared divided by the 192. So we observed 197 Republicans minus the 192 we expected divided by the 192, okay? Plus, I like to do the second one also. So the Democrat numbers is we saw 153 compared to what we expected of 172 squared divided by 172. And then you guys can go ahead and skip to the last one if you want. The last one is the other numbers. We saw 6 compared to the 8 we expected squared divided by the 8. Again, where am I getting these values from? I'm getting them from here. These are the observed right here. These are the expected. So observed minus expected squared divided by expected. Okay? And it goes all the way down that chart. Now, what I also did is I put those in my calculator. So all of those numbers, I also have them in my stat edit. Here's those numbers in list 1, the observed. I put my expecteds in list 2. And do you guys remember how I got these values? If you scroll up to list 3, you just got to type in the formula. List 1 minus list 2, observed minus expected squared divided by expected. And when I do that, it's giving me all those components. So you can write those values in if you want. I would say that's 0.13 plus 2.09 plus 16 plus 0 plus 0.5. So I like to write them in. You don't have to, but I went ahead and wrote them in. Now, how do we find the sum of those quickly? You can either add them up right like that, or remember the calculator will do it for us. I can hit, I'm going to first cancel out of there. I'm going to hit stat. I'm going to scroll over to calc, choose option 1 variable stat, and I'm going to tell it list 3. If you have one of the old calculators, just tell it list 3 directly next to 1 variable stats and hit calculate. Remember, it's the second one there. That's the sum of the x values. So it's 18.729. So 18.729. That is your chi-squared test statistic. But remember, we still got to turn that into a p-value. How do we turn that into a p-value? By doing chi-squared CDF. We're going to put the lower bound as 18.729 because that's the left side of the shaded region, all the way up to the upper bound of 999. And what about the degrees of freedom? Well, this is a goodness of fit, so we have to have the number of categories minus 1. So 1, 2, 3, 4, 5 categories minus 1 is going to be a degrees of freedom of 4. Now make sure you label these, that you know that this is your lower bound, you know this is your upper bound, you know this is your degrees of freedom. I want to see this information plugged in. So typing that into our calculator again, I'm going to go second distribution. Remember, it's option 8 for chi-squared CDF, and we're going to type that in again. 18.729, upper is 999 with the degrees of freedom of 4. So what do we get for that p-value? We get, when it says e to the negative 4, that means this 8 is the 4th value after the decimal. So another way of saying it is 1, 2, 3, the 4th value is 8. So it's a very, very small number. In fact, I'll even go out one more decimal and say 8, 9. So that's an extremely small p-value, and you want to make sure you indicate on there that that is indeed the p-value. So list that on your paper. So let's go ahead and do our conclusion. So our conclusion says, assuming the null hypothesis is true, I went ahead and just repeated what those percentages were. There is a 0.00089 probability of obtaining a chi-squared value of 18.729 or higher, purely by chance. Because that p-value is so small, this provides strong evidence against the null hypothesis, and it is statistically significant at the alpha level of 5%. And that's because the p-value is so much smaller than the alpha level. Therefore, we reject the null hypothesis and can conclude that voters in this election did not vote according to their registered affiliation. And I just got that sentence directly from right here. Do these data provide evidence that voters in this election did not vote according to their registered affiliation? Okay. Now, I get a lot of people that have still asked, what about the component piece? Well, I just rejected the null hypothesis. So look at the individual components. Look at the values that you had to add up to get the chi-squared. Do you see how 16 is the biggest component? That is the 1, 2, 3, third value. So what that means is if you look up here, 1, 2, 3, that is the Green Party. The number of people we saw was much larger than what we expected. So that's exactly what you say in that last sentence. The chi-squared test statistic is the one that's affiliated with green because those who voted for green was much higher than what we expected. So that's exactly what I said here. The largest component of chi-squared was 16. And that's because there were way more people who voted for the green candidate than expected. So there is your goodness of fit. Okay, let's go ahead and go on to the next question.